All right. Hello, everyone. This is Tian Bao. This is my capstone design project, and my project is to predict New York taxi fire. So the first presentation will be for the stakeholder. So when New York visitors come to New York, they want to know the best transportation tools. So they can look at the taxi, they can look at the trains, and they don't know the taxi fare, so they cannot make their good decisions. So visitors usually make a guess of the New York taxi fares, but they are inexperienced, so their estimation is usually inaccurate. And also the New York taxi fares varies not only by distance, but also by locations, by time, and many other factors. So the visitors usually ends up saying, "Oh, I'm paying such a high taxi fares, and I should just go with train or subways." So they actually the visitors do not have this ability to choose optimal transportation tools. So what if we can build an AI that AI can predict the taxi fares for those visitors based on machine learning models? Then they don't need to spend time think about what is the best price they should pay for a taxi versus a subway. So they can choose to between the price they paid and the time they saved using a taxi, and they can make a better decision. So to help them and make predictions on the taxi fares, I collected a comprehensive data set, including 100,000 taxi transactions between 2009 and 2015. So for each taxi transactions, the following information is collected, including the taxi fares, pickup times, including which year, which month, weekday, and hour, pickup and drop-off locations, and distance between the pickup and drop-off locations, and also the number of passengers. If we look at this chart here, this taxi fare distribution, we can find the most taxi fares is between $0 and $60, and most of them are between $0 and $20. And if we look at the chart on the right, we can find the most pickup and drop-off locations are concentrated in Manhattan area, and some of them are in LaGuardia Airport and JFK Airport as well. So with those information in mind, we are going to use the pickup time, pickup location, drop-off location, number of passengers to make predictions on the taxi fares. So we built a ridge regression model to predict the taxi fares, and the plot here shows the result. So on the horizontal axis is the true taxi fares, and the vertical axis is the predicted taxi fares. And the black line here is the perfect prediction, and we find the most blue dot here is our prediction is around this black line, which is great. And then when we do the calculation, we find that the difference between the predicted taxi fare and true taxi fares are only around $2.2 on average, which means people have a good sense of their taxi fares just based on our ridge regression model. So to possibly implement this model into a real world, we can build a mobile app, and that will only collect the information about their destinations, and all other information, including time, pickup locations, can be automatically generated by the app itself. So in this case, all the visitors to the US will have a good estimation of their taxi fares and make a better decision of which transportation tool they're going to use. Thank you for listening. This is so the next part will be the presentation for the data science peers. So for this POC, we use Python. I use Python throughout the project for both for ETL, for visualization, and for model building. For initial exploration, the NumPy and Panda package was used a lot. The data was initially stored in CSV files and imported Panda, and then did some initial exploration in Pandas. The visualization was performed using Matplotlib and also Plotlib packages. So the Matplotlib provide a quick view of the data, including a line plot, a scatter plot, or histogram. The Plotlib package, on the other hand, provide an interactive view. For example, when we look at the correlations, we want to have a detailed look of what exactly the correlation numbers are. where the interactive view can be very helpful. And for the machine learning tool, it's also built in Python, use rich regression models. So for the data cleanup and feature engineering, there are several steps. For the data cleaning, I first remove the missing data, which is only 0.1%, is very small percentage. This data have a high quality, and then I remove the taxi fares that are negative and above $100, which is unusual in New York area, which also is only 0.05%. And I'll also remove the data points where the pickup locations are outside of New York. Some of them are even on the sea and outside of US. So those pickup locations may not be collected correctly. So those are around 2.5%. So I remove those data as well. So for the feature engineering, the first thing I did is calculate the distance between the pickup and drop-off locations. This is very critical to the model building. And second, I extract the year, month, weekday, and hour information from the raw data. So the hypothesis is between different years, different months, different work days, and different hours, the taxi fares will be a little bit different. I also added another feature about whether this day is a holiday, assuming that in holidays, the taxi fares may be higher than a regular day. And I also use one-hot encoding for the month, week, and hour information because I don't think those information are linearly correlated and they are not linearly correlated to the taxi fares. So encoding them into category information will maybe helpful. So for the model evaluation, I use the mean absolute error because this is a regression model and predictions are numerical values. So looking at error is better than looking at the accuracy. So for the regression model, I built it as a baseline because I observed some linear correlations. So to train the model, I first split the data set into training data set, validation data set, and test data set. So the five-fold cross-validation was used for hyperparameter tunings based on the training and validation data set. The test data set was used for model evaluation based on the best parameters tuned from the training and validation data set. And as mentioned before, I used one-hot encoding for month, workday, and hour information. And it turned out by doing this one-hot encoding, the model performance got significantly improved. So for the next step, there are more things to do because this is just a POC. So more features can be added into the model, including whether there is a certain fixed fare between an airport location and a Manhattan location, and other nonlinear models should also be trained to see whether those models have a better performance. So that's my Capstone project, and thank you a lot for listening, and I hope you enjoyed this project, and thank you a lot for reviewing this project. Thank you. Bye-bye.